So we have given the problem partition to key equals some subsets. The question is, given an integer array nums and an integer k, return true if it is possible to divide this array into k non-empty subsets whose sum are equal. K non-empty subsets whose sum are equal means we have given an array and a integer k. So we have to divide this array in 4 parts such that their sum should be equal. Means I have taken a number 5 in a subset, its sum is 5, and 1 comma 4 in another subset, its sum is 5, 2 comma 3 in another, and 2 comma 3 in another. So their sum are equal, and we have divided this array, they are non-empty, in four parts, and we have taken all the numbers, not like this. I have not taken one and I have divided the array. We have to take all the elements and divide into 4 parts. Okay, so first thing, what first of all, what is the thing that come into our mind now? How, if this sum is, if this sum, let's say this sum is 21. Okay, this sum is 21. So can I divide this sum into 4 parts? Can I? Like, if I'll say one subset will be 5, another will be 5, another will be 5, and another will be, obviously it is 15, so another will be 6. So uh, we will never able to partition this in k parts, like the 4 parts, when their sum is equal. So when we will able to, when we will able to part when we will able to divide this array into subsets of equal sum, then when their sum, let's say this sum is 4, 3, 7, 2, 9, 12, 17, 19, and 20. This array sum is 20. Okay, now it is divisible by k if only, if and only if it, the sum is divisible by k, like 20 is divisible by 4, which is equal to 5, then only we will able to divide it into 4 subsets whose sum is equal to 5. The only thing, the only condition is when this sum is divisible by 4 and this sum is divisible by 4 and the subset we will divide, those sum is equal to 5, then only we can divide it into k subsets which are non-empty and their sum will be equal. Okay, so this problem is a DP or backtracking problem. For why backtracking problem? First of all, DP why? So we have to think. Can I take 4 in, let's say I have 4 subsets. These are 4 subsets. 1, 2, and this is 3, and this is 4. So I have to think, like 4, can I take 4 in this subset or not? This subset or not? Let's say I have taken. Now I have to think, can I take 3 in this subset? No, I can't. Why? Because the sum should be the subset, individual subset sum should be 5. So if I take 3, it is greater than 5. I can't. So can I take 3 here? Okay, you can take 3. Now 2. Can I take 2 here? No. Can I take 2 here? Yeah, I can take. So I have taken. Can I take 3 here? No. Can I take 3 here? No. Can I take 3 here? Yes. I have taken. Can I take 5 here? No. 5 here? No. 5 here? No. I have taken 5. Okay. Now, can I take 2 here? No. Can I take 2 here? No. Can I take 2 here? I have taken, okay, 2. Now 1. Can I take 1 here? Yeah, I have taken. So I have to think which number I can take in which subset. It is not necessary. It is not necessary that this number will come in this only. Am I right? So this is a DP problem. Now why backtracking? Backtracking is we have to. This is, so we can see, okay, now this is becoming 5, this array sum. So we will not traverse whole array. Why? This array, I am checking this array sum, the existing array sum is 4. So if I take 3, it will become 7. So then I am saying, okay, I can't take. But we will not continuously, we will not frequently check its whole sum. We will not again and again check this sum is equal to, this sum is equal to some subset sum or not, this sum is equal to subset sum or not. So this is a backtracking problem. We will take 3, okay, then we will check it is becoming true or not? It is becoming true or not? Let's say what I have done. This is our solution. First, what I have said, I will take a sum. Sum is this is a short form of finding the sum. So you can find by traversing with a for loop. So it is the sum of this array, this nums. Now this sum module k is not equal to 0. Means the sum is not divisible by k. Then we will say simply return false. We can't divide it into k subsets. Okay. Now if sum size is less than k, means we have to divide this array. This array is having 1, 2, 3, 4, 5, 6, 7. This array is having 7 elements. If k is 8, then how can we divide it in non-empty subsets? So this will false. Now what I have done, sum is equal to sum divided by k, because I have to find the array having the subsets having sum is equal to 5, because the only way is the only sum will be 5, then only they will equal some subsets. So I have taken sum is equal to sum by k. Now I have sorted it. Why sorted? Because I want to check if I have let's say if I have taken 4, if I have taken 4, then if let's say it is sorted 1, 2, 2, 3 and 3. Let's say it is sorted and I have taken 1, then I have taken 2, it is less than 5, and I have taken, let's say, 2. Okay, it is equal to 5. Now I have taken, let's say, 3. So it is greater than 5. Now if it is greater than 5, I will not go uh, I will not go uh, I will not go the in the direction of I will not go again here. I will not increase my pointer. Why? Because at this point the sum is greater than 5, then why I will traverse the array? So to make it simple, I have sorted. Now after sorting, what I have done, taken a visited array, like to check if it is we have taken or not. This number we have taken or not. This number we have taken or not. So what we will do, we will individually first not we will not the full we will not fill the all the subsets in one times. We will fill first. We will say okay, I am filling this subset. If this subset is this subset can I able to make 5 or not, then I will fill this subset, then I will fill this subset. If this is not, I am not able to fill this subset, then I will backtrack. I'll say you are not right, I have to fill you again. Are you understanding what I'm saying? So this I have taken. Now solve. In solve I am saying you have sum and k and nums visited, and the r 0 0 is our index I and current sum. Current sum by what I have said, I am checking its sum is equal to 5. Now its sum is equal to 8. So this is current sum is indexing this 8, right? The current sum is greater or equal than 5 or not. I am checking the current sum with the sum. If k is equal to 0, right? If k is equal to 0 means I have partitioned the array in k subsets, because I am decreasing the k. I am reducing the k by 1. Okay. So now at any point if current sum is greater than sum, then I'll say I can't partition this subset into with these numbers because it is greater than sum. Now if it is equal, what I am saying, I will fill the subset one by one. So let's say k is 4. First I am filling this subset. So I have filled this. Now I am saying what I'll do after this. I'll fill the third subset. In backtracking, I am taking the k and reducing it, the third subset. Then I'll fill the second subset. Then I'll fill the first subset. Then I'll call for the k is equal to 0 subset. When k is equal to 0, I'll return the true. So if I have filled this means this current sum is equal to sum. So I have filled this correctly. So after filling it, what I'll say, okay, you call again for k minus 1 subset, or to fill the k minus 1 subset and nums visited, and our index will be again from the 0, and current sum will again will be 0 because I am filling the new subset. Okay. So now what I have to do, I have to traverse the array from int j is equal to I. I is there. Where is the I? I first I am taking from 0. I can skip some number, or I can take some number. Which number I will skip? Which I have taken. Like say there, if visited of j is true, means I have taken this number. I have taken this number in my previous subset. So I have taken this number, or this number plus my current sum is greater than sum. If this number, sorry, if this current number and my current sum is greater than sum, so I will not take this number in my subset. Why? It is making my subset exceeding the sum which I want. So I can jump. I will jump. So where I am starting from the ith index. Now let's say I have, if it is not exceeding the conditions, I'll say okay, I am taking this number. So visited of j is equal to 1. Now if I have taken this number, I'll say if I have taken this number, now I'll say you go to j plus 1 index. Just the next index you go, and the current, what will be the current sum? The current sum, in current sum we will add this number because I have taken this number. If I will call again, if this call is true, if this call is true, means the recursive call is true, then I'll say okay, this is true, so return true, means this subset is true. Now call for next subset. Now after this, let's say it is not true, it is false though. So if it is false, then when we will backtracking, we'll say okay, you mark this index or this element. Let's say the j is at 3, so this element false, means I have not visited, and the current sum if, and at any point current sum is 0 if, so we will break. What we'll do, we will break, because current sum is, if current sum is 0, then we'll say we don't have to worry about this. Now if after all this it is not returning true, so I'll say okay, you return false, you return false. Now I'll run this code. So I can submit. It is giving true. It is submitting successfully. So this is only the approach. What we are doing. What we are doing. We are checking if sum is divisible by k or not. Now, if it is divisible by k, then I am checking sum divided by k. The this sum we want, every subset we want this its sum will be equal to this sum. So now I am sorting it and taking a visited array. So 2, 3 are base conditions. If k is equal to 0, then it is true. I have partitioned. I have divided array into k subsets. Now, if at any time current sum is greater than sum, then it is false. We can't take. If it is equal, then I'll say check for the next subset. Now though now I am filling the subset. For to fill the subset, I will start with index I and 2 nums of size. And if it is visited, I will not take, and or if it is exceeding my sum, I will not take. Otherwise, I will take, and I will call for the next element. Like you try to fill the next element. If it is if it is true, then return true. If it is not, then when backtracking, I'll say okay, you mark it as not visited, and if current sum at any point current sum is 0, then break this loop, and after all return false.